I'm Joe Grout, and while on an internship with the Air Force Research Laboratory, I had an opportunity to run an experiment with concrete 3D printing under the supervision of Dr. Hojita and Dr. Torres. Prior to this, I had printed this object with a traditional plastic 3D printer. Now you'll see that this is a complicated enough object that if we were making it with a mold, you wouldn't be able to make it in a single cast. But with 3D printing, I was able to make this in one print. This is possible because the printer adds in removable support structures. These support structures allow us to make a much more complicated shape. And I think that's a really important principle of 3D printing. With that in mind, I wanted to look at the viability of using sand as a support material. As I developed this with my advisors, we developed a series of tests that would test whether or not the support material would also reduce the need for buildability in the mix design. This would be valuable because buildability is one of two contradictory demands needed for 3D printing. We need the mix to be sturdy enough to support additional layers, and we need it to have a low enough viscosity to be pumpable. To do both right now requires a very expensive mix design. To test this, I wanted to print a series of domes. I wanted to see how each of these behaves as we gradually reduce the buildability in the mix design. Obviously, I expected the dome with no supports to fail first. As we continue to reduce buildability, I expected to see the solid dome deform before we see the same failure in the interior supported dome, again suggesting that the support material is reducing that need for buildability. But if we continue to reduce buildability, I suspected that we might even see the dome with interior support fail before we see the same failure in the dome with surrounding supports. I believe that was going to be the best method for supports. This is because I believed in spite of any additional pressure from additional layers, there's nowhere for the print to deform laterally. My first print was a control, and as you see, even the dome with no supports relatively managed to maintain its shape. On the next print, I increased the water content, and we start to see some proper failure in the unsupported dome, but no other changes. On my next print, I increased the water content by an additional 10%, but that proved to be too watery to be printable, so I continued to use the water content from this second print. Now, because I hadn't seen the failures I wanted to do to increase water content, I had to increase the scale of the domes. And I don't know about you, but to me, the dome on the right, the solid domes, to me feels slightly less spherical than the supported dome. I think there's some difference there, but I really didn't feel that was very conclusive. But at this point, I ran into a problem because I had reached the limits of my material capacity I had allocated per print. So I'm not getting the results I want to see. I want to start to see failure like this, but I likely need all this extra material to do that, and I don't have that. But it occurs to me that all this is just extra material. I need to find an alternate method of applying weight to my prints to simulate those layers. On the following prints, following the completion of a dome, I have gradually applied weight to the domes to simulate that layer weight. The unsupported dome reached this point of failure under only 11.5 pounds. The dome with interior supports reached this point of failure with 43 pounds applied to it. The dome that had the surrounding supports was placed under 42 pounds. It looked like this. It showed little to no sign of deformation. Here it is next to a solid dome that was printed from that same batch So it seems to be the case that sand as a support material might be limited only by the strength of the retaining walls, although that would certainly require additional testing at larger scales. But I believe this begins to demonstrate the viability of sand as a support material and the possibility that it has real potential to reduce that need for buildability. But I still had this notion that the support materials can increase the complexity of our printed objects. I was able to print this, and while, if anything, I'd say it's more artistic than it is functional, I believe it is a successful example of how 3D printing can increase complexity. And I believe it is, more precisely, what that is optimizing material placement in 3 dimensions. 3D printing is already very good at optimizing material placement in 2 dimensions. Or for example, this corrugated wall where on the horizontal cross-section we can see the pattern. But with support materials, we can optimize material placement in 3 dimensions, or in other words, a corrugated wall where we can see the pattern both on the horizontal and vertical cross-section. I believe this starts to demonstrate some of the potential of support materials in 3D printing. I believe that we can reach a level of complexity that we could have never imagined getting out of concrete. Thank you.